Hello everyone, I'm Connor Klebrowski. We're doing section 2.3, number 34 from the homework. We're doing all three parts, so buckle up. Let's get right into it. So suppose functions g is from a to b and f is b to c. We're doing part A, I already got it set up. If f composed of g is 1, 2, then f must be 1, 2. Now let's prove it. Let us make C arbitrary in C of C and A of A such that F composed of G A is equal to C. Now let's reorganize this equation. We have F of G of A is equal to C. We know that G of A takes us to set of B, therefore is contained in B. Let's make B of B such that G of A is equal to B. Let's plug this in. We have F of B is equal to C. This demonstrates that this equation is 1, 2 because for every element in C, there's a corresponding in B through function F. Therefore, F is 1, 2. Take a look at it. I'm going to come back to you with part B. I set up part B, so we need to prove that if f of composed of g is 1 to 1, then g is 1 to 1. So let's get into it. Let us make a and b of a such that g of a is equal to g of b. Now if we're able to prove that a is equal to b here, then we show that g is 1 to 1. So let us use what we do know. So we know that f composed of g of a is equal to f composed of g of b. And let's move around this equation a little bit. So through here, we understand that the only way that these two equations work and are equal to each other is if A is equal to B. And since A is equal to B and G of A is equal to G of B, we know the injection, that is, G is 1 to 1. Therefore, we've proven the statement. I'm going to come back to you when I set up part C. Thank you. Hello everyone, so I set up part C. We're trying to prove if f composed of G is a bijection, then G is 1, 2, if and only if f is 1 to 1. Now since this is an if and only if statement, we get two statements that we have to prove in order to prove C. Let's focus on state 1. So if f composed of G is a bijection and G is 1, 2, then f is 1 to 1. Now let us make G or x of 1 and x of 2 in B and A and B of A such that G of A is equal to x1 and G of B is equal to x2. Now let us consider the function f of x1 is equal to f of x2. Now if we're able to prove that x1 is equal to x2 and f of x1 is equal to f of x2, then we show that f is a 1-to-1 function. So let us substitute these two equations. So we're going to get f of g of a is equal to f of g of b. And let's move this out. So we get f of g of a composed of g is equal to f composed of g of b. Thus, we know since it's a bijection, then A is equal to B. And if A is equal to B, we know that G of A is equal to G of B. And if G of A is equal to G of B, then we can just substitute this in, and we know that x of 1 is equal to x of 2. Thus, since x of 1 is equal to x of 2, and f of x1 is equal to f of x2, we know that f is a 1-to-1 function. And this proves the first part of part C. Let me set up part 2 for you guys. So I set up the second part of part C. So we're trying to prove that f composed of G is a bijection and F is 1 to 1, then G is on 2. Now in order to prove this, let's let B of B, and we know that F of B is in C. Let's make A of A such that F composed of G of A is equal to F of B. Now let's rearrange this function. So we got F of G of A is equal to F of B. And through this equation, we know that G of A must equal B. And through this, we know that G is an onto function because for every element in B, we can map it through function G that there's an element in A corresponding to it. Therefore, G is an onto function. And since we've proven the first and second part of part C, we know that the thesis of C holds. And with that, we've completed the whole proof of part A, B, and C. Thanks for watching. I hope you guys have a great day.